Hello, my lovely students. Welcome to Maths GPT. Today we are going to start the class 12 chapter relation. Relation. First of all, we know we should know Cartesian product. Cartesian product. The set of all possible. The set of all possible ordered pair. The set of all possible order pair order pairs A, B, where A belongs to A and B belongs to B is called the Cartesian product. Cartesian product of A to B and is denoted by is denoted by A cross B. Now example, A equal now first set A equal to 1, 2 and B equal to A, B, C, then find A cross B and B cross A. A cross B, A cross B, A cross B. The first element from set A. The first element from set A. So 1, A, 1, B, 1, C. Then 2, A, 2, A, 2, B, 2, C. Now B cross A. Now B cross A. This is the first set B. So we write first element from B. First element A. A, 1, A, 2. B, 1, B, 2. C, 1, C, 2. If number of element equal to m and number of element B equal to n, then number of A cross B equal to m into n. Now this usually A cross B not equal to B cross A. B cross A. B cross A. Now just Cartesian product just like this one and this two. This is 1, this line 2. Just 1, 2 or 2, 1. 1, 2. 1 is the first and this is the x-axis. So 1 or 2 this point and 2, 2. This is the x-axis and this is the y-axis. So 2, 10. So this point or this point how to equal? So A cross B not equal to B cross B. When equal? One sum. Just 1, 2. Just one set A equal to 1, 2. A set B equal to 1, 2. Then 1, 1, 1, 2, 2, 1, 2, 2, just 2, 1, 1. Then equal. Now relation. Definition of relation. Now relation. Let A and B be two sets. Let A and B be two sets, then a relation R from A to R from A to B, R from A to B is a subset of A cross B, subset of A cross B. Now example, relation, let A and B be two sets, then a relation R from A to B is a subset of A cross B. Now A equal to 1, 2, 3, 4, 5, 6, 7, 8, and B set 1, 2, 3, 4, 5. Now and R relation R, now relation A comma B, A equal to 2B, and A belongs to A and B belongs to B set. Then R is, and this condition fulfilled, just A equal to 2B. A is the first set of, A is the element of first set. The first set is 2, and then second set of B is the second, B is the element of the second set. This is 1. So 2 equal to 2. So A equal to 2 or B equal to 1. So sum 2, 1, 4, 2, 6, 3, 8, 4. 8, 4. Then this is a relation. Now mapping diagram. You can also now write mapping diagram. Diagram or arrow diagram. We can say arrow diagram. So this relation, mapping diagram, arrow diagram, just this is the 1, 2, 4, 2, 4, 2, 4, 6, 8, and this relation 1, 2, 3, 4. We also 2, 1, 4, 2, 6, 3, 8, 4. This type. This is the mapping diagram, and also we can say arrow diagram. Now note, n number of A equal to m and number of B equal to n, then A number of A cross B, then number of A cross B equal to m into n. So total number of subset of A cross B, also that is the number of relation from A to B. Number of relation from A to B is 2 to the power m into n. 2 to the power m into n. A total number of subset across B are the number of relation from A to B. 2 to the power m into n. Now domain ring. This page also use domain and range. Just leave are relation A to B at A to B. First of all, domain. Domain. The set of all first elements of the ordered pair belongs to R is called the domain of R. Called the domain of R. Now range. The set of all second elements of the ordered pair. The set of all second elements of the ordered pairs in R is called the range of R. Called the range of R. First elements of the ordered pair belongs to R is called the domain. First element is called say domain, and second element can say range. Now if you have one question written, let equal to 1 3 5 7 and 1 3 5 7 and b equal to 2 4 6 8 be two sets, and let R be a relation from A to B such that relation x comma y belongs to R equal to x minus y greater than 0. Then find the domain and range of this relation. Then find the domain and range of this relation then R relation or x minus 1 greater than 0, so 1 minus 2, so minus 1 not equal 3, so 3 comma 2, 3 comma 2, 3 minus 4 equal to minus 1 not greater than 0. So this is not set in this element. Now 3 5 comma 2 comma 5 comma 4 7 comma 2 7 comma 4 and 7 comma 6. Then first element the domain. Now written domain is the first element. 3 5 2 times, but in set in domain only one times, 5 and 7. Now range second element, this is 2 times 2, but only written one times, 4 and 6. So this is the range and this is the domain of relation. But we study details of range or domain in function topic. So now types of relation. Types of relation. First, wide relation or empathy relation. Wide or your empathy. Empathy relation. Empathy relation. Let A be a set. Let A be a set. Then this is phi. Phi subset A cross A. Phi subset A cross A. And so it is a relation on A. This is called the wide relation or empathy relation. Wide relation. Wide relation, you can say empathy relation 1A. Now example 1, 2, 3, 4. Now R relation A, B, A, B, A, B, then this A plus B greater than 10. And any number of relation this condition satisfies just 4, 4. This is greater equal to 8. This is greater than 10. No. So no any element in this set. So this is a wider empathy relation. Just R is called empathy relation this. Now universal relation. Universal relation. Universal relation. Let A be a set. Let A be a set, then A cross A subset of A cross A, and so it is a relation on A. So it is a relation on A. This relation is called this relation is called universal relation on A. Now example 1, 2, 3, 4, and relation this condition A, B or A plus B less than 10. A plus B less than 10. So also this now is the universal relation. Now identity relation. Third, identity relation. Then I A to A and I A equal to A, A. A belongs to A. That is if every element of A, is related to itself only, then it is identity relation. Identity relation. This word is important. Only itself only. otherwise not identity relation. Now example 1, 2, 3 and relation a, b, a divided b equal to 1. Only for relation it is this is 1, 1, 2, 2, 3, 3 and 4, 4 not in 3, 3. Then this only itself only, otherwise no any element can include, otherwise other element include set. This is not a identity relation. Now reflexive relation. Reflexive relation. Reflexive relation are a to a and if every element of element of a is related to itself, then it is reflexive relation. Then it is reflexive relation. Now example 1, 2, 3 and condition relation a comma b, a comma b, a divide b belongs to integer. The reflexive identity when itself only, but reflexive itself, but otherwise not only condition, only itself only for identity relation, reflexive itself. Just like this is just some example another way. Just like identity relation is just like one set 1, 2, 3. Then this is 1, 1, 2, 2 and 3, 3. Otherwise no any element. So this is identity, but reflexive just 1, 1, 2, 2 itself and 3, 3 and just like 1, 2. That this element 1, 2 also add, but itself then reflexive. But this is not identity because only this identity 1, 2 add. So this is not a identity. This is a reflexive relation. This understood? Now reflexive. Now symmetric relation. Now symmetric relation you can also one note before the symmetric relation. One note, every identity relation is reflexive. Note, you can also write one note. Every identity relation is reflexive relation. Is reflexive, but every reflexive relation is not identity, and also written on non-note. Every identity relation is reflexive, but every reflexive relation is not identity. Now symmetric relation. symmetric relation. Relation A to B is said to be symmetric relation if A comma B belongs to R implies B comma A belongs to R for or A comma B belongs to A. Now example, one comma 2 comma 3. A relation just A comma B and A plus B less than 5. A plus B less than 5. So just in this relation 1 comma 2 1 comma 1 1 comma 1 1 comma 2 1 comma 3 2 comma 1 2 comma 2 2 comma 3 not allowed, 3 comma 3 not allowed. Now transitive relation. Reflexive symmetric transitive relation. Then transitive relation A to B, A to A, also written A to A, not A to A to A, A to A, A to A, A to A relation. A to A is said to be a transitive relation if A comma B belongs to R and B comma C belongs to R, then A comma C belongs to R for all A comma B comma C belongs to A. Now example, example 1 2 3. A relation A comma B, relation A comma B, A less than B. That's some example, just A less than B, this 1 comma 2 and 2 comma 3. This condition 1 also less than 2, 2 less than 3. So then A comma C and A comma C, this condition. So 1 comma 3, 1 also less than 3. So this condition, so this is the transitive relation. Now equivalence relation. Equivalence relation a relation which is reflexive symmetric, and transitive simultaneously. three relations satisfied reflexive symmetric contraction, then this is called equivalence relation. Now some note wide relation is symmetric as well as transitive but not reflexive. Second note, number of reflexive relation equal to 2 to the power n square minus n, and number of symmetric relation 2 to the power n square plus n upon 2. Thank you.